Welcome to my second Korg Volca modular tutorial. In the first one we showed how the Volca modular can sound like some well-known and simple non-electronic instruments like a clarinet, horn, bass, piano, all those sort of things. In this one we're actually going to do a slightly different thing and make the Korg Volca modular sound more like the synthesizers that you're used to. Now, just a first one, I know everyone normally talks about East and West Coast synthesis. You get Volca and you get Moog, and really what it boils down to is the East Coast synthesis is more concerned about the signal path for the audio. For example, you have an oscillator going into a filter, going into an amplifier with an envelope. And I mean, that's the basic voice. Yes, you can do a lot more other things. You can put in vibrato, you can change various different things, change the filters for both the filters and amplifiers. But on the whole, that's what it boils down to. Whereas in the West Coast side, it was more about experimental music, basically doing things which didn't really sound like the conventional music at the time. And so they have slightly different functionalities. Now, as we said before, a standard East Coast synthesizer would have a complicated waveform, and by that I mean something like a square sawtooth pulse going into a filter, and that filter can cut back some of the harmonics or frequencies, which changes the way it sounds. It's like sculpting the sound from a raw bit of material. And then just to sort of top it off at the end, you have an amplifier where you can change the envelope. So does the sound start very quickly? Does it take a long time to come in? Does it decay rapidly or slowly? Anyway, on the Korg Volca modular, we don't really have those components. The closest we have is actually our source section, but we'll get to that in a sec. We don't have a dedicated filter or a dedicated amplifier. In the West Coast style, we have low-pass gates. It's actually a bit of a combination of a filter and an amplifier. So, okay, what does that do? Well, the one thing you can't, or at least not on the Korg Volca modular, is you can't sweep the filter. Those stereotypical 70s and 80s filter swept sounds, like the wah-wah pedal type sounds. What you can do, however, is you can set what we call the final filtration. So, for example, there's our standard boring triangle wave. Now, all we have to do, and I might have to turn this up just a little bit. You're hearing exactly what I hear. This is going through what's actually going through a piano, electronic piano, and what I hear is what you're hearing on the recording. So anyway, there's a triangle wave. As we turn down the filter, you'll hear it cutting out the frequency. So I'll just hold down the triangle wave. And there's pretty much a sine wave. Triangle waves are very, very similar to sine waves. There's only a few of the odd harmonics in quite low levels. So a little bit of filtration turns a triangle wave into almost a sine wave. And that's how you can get your flute sounds and things like that. But basically what our low-pass gate is doing is as the control signal comes in to open up the volume with our envelope, it increases the cutoff of the filter, pretty much like a filter sweep, but you have very little control over it. The final value of that sweep, in other words, the value that it gets to when the note is fully on, is static. It's programmed by the knob there. Now the other thing is filters will actually cut out volume. So as it filters out harmonics, you're left with just the lower harmonics. But once the filter goes below the frequency of those, all it's doing is making it softer. So the further you twist the filter to restrict everything, it actually ends up being a lot slower to ramp up the volume, because you're actually competing with both the filter and the volume. So you can hear how when the note finishes, it's a very abrupt clunk. So when you turn it down, you normally have to add a little bit more, in fact a lot more decay. So if you listen to the note, now if we turn the filter all the way up again, hear how long the note stayed along? That's because not only is the envelope making it quieter, but so is the filter. Anyway, so that's the filter section. Now the next one is, in a West Coast, or especially in the Volca modular, we have a source section. Now the reason it's called a source and not just a modulator or an oscillator is that it's actually a complicated oscillator. There are actually two of them. There's a modulator and there's a carrier. There's a wave folder. You can change the ratio and you can alter this on the fly. So if you think about it, on an East Coast synth, when you turn on triangle wave, it's a triangle wave, and that's all you get. If you turn sawtooth, you get a sawtooth. Square, you get a square. Now pulse, you can change the pulse width, so that's the one where you could argue that it's similar, but in the Volca modular, you can modify the waveform on the fly, and basically that's how we shape the sound. Because in the East Coast traditional type synthesizer, you get a complicated sound and you subtract harmonics to get the sound you want, hence subtractive synthesis. In the West Coast style, we take a complicated oscillator and we add harmonics, additive synthesis. So let's go back. In the previous video we made a clarinet sound. So how did we do that? Well, what we're doing, this is just the basic startup. So everything's low except for the filter, which is all the way open. Triangle. So what we're doing is we're using the wave folder to add harmonics. Now, as the wave folder starts folding the wave back, it goes through a few stages. Now, in its early stage, the top of the wave is just sort of bouncing across, and it looks a bit like a square wave. So we start to get those harmonics of a square wave, which squares tend to sound hollow, like a reed instrument. Sawtooth tends to sound buzzy. A triangle sounds like an ever so buzzy sine wave, and a sine is just a pure note with no other harmonics. So what we've done is we'll start up, we'll put into the wave folder, we'll just put the envelope. So as we press the button, the envelope ramps up and it will turn on the fold. Now that envelope, the attack was instantaneous, so we immediately get that fold. And if you compare the triangle to the wave folder, you can hear all those harsh harmonics, the buzziness of it. Now you can even do it better. If I turn the attack right up, you can hear, in fact I'll give it a bit of delay just for the effect. So I press the button, the wave folder will ramp up, and then as I let go it'll ramp down, a bit like a sweep. And you can hear right at the end there, very, very pure, it's almost a sine wave. But that's not really what we want. That's too harsh. So what we did was we went into our math section and we go into B, because that math section is A plus B times C. If you don't put anything in A, it goes to 0. If you don't put anything in B, it goes to 1, or high voltage. And C is whatever the dial is. Now if you put a wire in C, it adds whatever you've got in there to the value of C. Anyway, so we're going to take A plus B times C. We know A is 0, so it's B times C, and put it into the wave folder. we'll turn C all the way down. So we'll go back to a bit more normal. So there's our triangle. Now as we turn there's our clarinet-like sound. It has that hollow square wave sound. So that's great. We have, however, already used our math section. We've only got one of those. That's the one thing I'd really like to have another one of on the Volca modular. Now we've used our folder and we've used our math section. So all we're left with is basically a second low-pass gate, because remember that's automatically going into the first one. We've got a second low-pass gate, and we've got our second function generator, and we do have the folder, the frequency modulator. So, okay, is there a different way to do this? Can we still get a square wave sound without using the folder? Because our folder is like our filter sweep. We actually like the folder. We like to be able to use it for other things. So, here's a trick. The answer is yes, we can in fact get a square wave sounding wave from our oscillator without using any wiring. Now I'm just going to put a wire in now so you can hear, but what we're going to do is we're going to use the frequency modulator. Now whenever you're tuning, the best way to do it is to connect the two sources together, and what that actually does is that will play both notes if you get it right. So you can hear how there are two notes. We can now tune that with the ratio button, and you get some really quite strange effects. But what we're looking for is ratios, and the reason is we talk about harmonics. Now a sine wave has a single harmonic, in other words a single frequency of whatever the frequency is of that wave. When we use a triangle, a saw, square wave, a pulse, we talk about added harmonics. Now the way it works is you can add two sine waves together and get another wave. If you add enough of them together, strangely enough, you can get a nice rounded sine wave to look just like a square wave. In fact, that's what they do. Now, for a little bit of maths, square waves contain all the odd harmonics. In other words, whatever the fundamental, whatever the frequency you're playing, is 1. And then 3 times that, 5 times, 7, 9, 11, etc. And each time you go up, the frequency, the volume of that frequency decreases. Sawtooth waves have every harmonic, so it's 1, 2, 3, 4, 5. So if you were to have a 500 hertz note, you would have harmonics at 1000, 1500, 2000, 2500, etc. Anyway, that's determined by the ratio. So what we're going to do is we are going to go to a ratio of 2 to 1. And the reason is that when we use frequency modulation, the harmonics you get it's a series, but it basically is determined by the modulating frequency. So if you go back to our example, if you have a 500 hertz note and a 1000 hertz modulator, you will get 500 hertz, you'll get 500 plus 1000, that's 1500, which is the third harmonic, so 5, 100, 1000, 1500, and then you'll get 2 lots of that 1000, so add another 1000 is 2500, 3500, and basically that's every odd harmonic. So what we're going to do is we're going to get our modulator to 2 to 1. That's 1 to 1. Now, you probably heard as we're going up and down, you get these beat frequencies. That's basically the two way of frequencies interfering with each other because they're very close. Now on the modular, when you get very close to the correct frequency, in other words, an exact 1 to 1, 2 to 1, 3 to 1, etc., there's a little minor detent, like a digital detent. It will stick there for just a tiny bit. So go up, down until there's no there's no beating, there's no interference. So those are now perfectly tuned. So we can take out our wire. Now, back to our triangle. What we do now is we increase our mod. Now, depending on the mod, you can get different sounds. That's not just one particular sound. So as I turn it up, you'll hear that it'll start to make a difference. Then it might beat a little bit, so I get a bit of a funny interference, and then it'll go back to being normal, like in other words, a single tone, and then everything goes belly up, and you'll hear just a really distorted tone. The idea is we go until we get that distortion, and then we back it off just until the point at which it's all sounding nice. Now the other thing is, just the way the Volca's set out, different notes need different modulation amounts. So basically, if you're staying inside the one keyboard, if you tune to the lowest note, it won't go out of tune. So what we're going to do is press the lowest note and put up the mod. So you can hear. There you are. There's our beating. We can go back and there. So now we get. And if you can hear, that's our hollow sound. It's got a little bit of a buzz at the beginning. Now you can do a couple of things. You can either wind the mod down, or you can actually put a bit of filter in. But for now, we'll just wind the mod down. So we've now changed the envelope a bit. There's our clarinet sound. Bit of reverb. So, as we know, clarinet sound is a square wave. There's a square wave. Now, we've used no wires, we've used no other sections, we've just used our complicated or complex source to generate a wave which, if you looked at it under an oscilloscope, it probably wouldn't look like a square wave, but it has all the right harmonics, and so it tricks your ear into thinking that it's a square wave. Now, one interesting thing you can do with a square wave is you can use pulse width modulation, and so you can make the pulse width shorter or longer, and that changes all of the harmonics, it changes the buzziness. And can we do that on the Volca? Well, yes we can. So what we can do this time is, instead of letting the source go directly into our amplifier, our low pass gate, what we're going to do is we're actually going to change the voltage on it. Now again, because we're a West Coast synthesizer, we are more interested in changing voltages than just straight notes and frequencies. So what we can do is we can take the output from our source into our math section, into the A, and then if we subtract or add B plus C, it'll move the whole waveform up or down. So if it originally was at 1 volt, it could become 2 volts. Now the trick with that is once you get past the point at which it can't go up any higher, because that's the voltage of the system, it will stay there, and so it basically becomes a flat line. So you get the lower part of the wave and then a flat line. And what that actually does is that ends up like a pulse width modulator. Because our square wave isn't exactly a square wave, we do have sides, it looks a bit like a triangle. We actually are able to change the width of the pulse depending on how we go up and down. So let's do that. So here we'll go into A, and then what we'll do is we'll try both, and I'll tell you which one I always use afterwards. If we go A plus B times C, and we'll put that into our input. Make sure we'll turn C away. So there's our normal squarish wave, and if we turn C, listen what happens. You hear how the sound changes. It's actually changing the width. Now, on my particular unit, and it may be for everyone's, but on my particular unit, A minus B times C has a much better effect. A plus B times C, you heard what it does, but to compare the difference, we now go to minus, do the same thing. Oops. There's a trouble about the Volca if you don't get the... Let's try and get it in the... There. So, as we turn C, we get a sound that sounds very much like pulse wave. Now, okay, we now can do something with that. So, let's control, instead of having to dial in C ourselves, let's control it. So if we take the output from the envelope, so that gets louder as we press the note and then softer at the end, we can put that into B. So instead of B being always high, we can now control it. So if we, we'll just put lots of attack into K just so you can hear the sound. Again, one trouble with the Volca module is sometimes getting it into the little holes. But you can now hear, as the note starts, it's more a square than it goes into our pulse. Like a wah. Now, if we choose the attack, there we have something that doesn't either sound, well, it sounds similar to a filter sweep or a pulse width sweep, but we've got a sound that changes over time. We can put a bit of reverb in. Or something like that. And we get a... We get quite a nice sort of 1980s type sound. Now, okay, a few of you are probably saying, well, it doesn't sound exactly the way I was used to. Now, there are a couple of reasons for that. One, we are actually emulating square waves, but the second is we've got what's called a linear change. So as the envelope comes up, it changes the value of our pulse width, but in a linear fashion. Now, it can actually be quite nice to use what's called exponential. So, can we do that on the Volca modular? Well, of course, the answer is yes. So how do we? Well, at the moment, we're multiplying B times whatever this value is here, which is linear. What would happen if we put B, or that value, into both B and C? Then it's actually B times B, which is squared, which is like an exponential. So, how do we do that? Well, we'll use the splitter. So I'll come up here into our splitter. Let's see if we can actually get all the wires properly in. And then one into B. Oops, didn't want to stay. And one into C. Let's go back into here. So now we've changed the sound. I mean, that's probably a little bit too much. I don't think anyone had ever used that, but you can hear that there's a lot more range. So we turn C, that's where we want to end up. And you can change your attack and decay to get different effects. So we've actually got, either you could call it a pulse width modulation, or you could call it a filter sweep, but that's getting the sound of more traditional synthesizer, and we've still got our fold, because think with fold we can still do some weird and wonderful stuff. We've got our second envelope, and we've still got a few other tricks to play. Okay, the next thing is, okay, we've talked about square waves. Well, what about a sawtooth? I mean, sawtooth is our, I mean that doesn't sound too unlike a brassy instrument, but that's because we're playing at the pulse width. What if we could get a sawtooth wave? So first of all, I'll turn it, there's our square, we'll turn down the reverb, so there's our square. We can now change the ratio from 2 to 1. Now if you remember at the beginning we said that 1 to 1 gives us all the harmonics, which is actually the same as a sawtooth. So you can either do the same trick of putting them together, or you just listen. So I can keep the fold the way it is because it's low enough, I think, so it won't go crazy. But if we press the note and then turn it down till we get another stable note, so there you can only hear one note. We can now turn up the fold again till it starts distorting, and then just go back a little bit. There we are. So there's a nice buzzy saw, and we can also use a pulse width modulation. Now normally that's not something you do with saws, but we can on this. Okay, and we can put a little bit of reverb on just for effect. Now hopefully you won't mind, but there's a guy who does great reviews, Starsky Carr, and I remember he was doing, I think it was a Behringer Crave demo, and he had a nice little riff that he was playing, and hopefully he doesn't mind if I use it here. And that's a very brassy, sawtoothy waveform that we can now generate from a Volca modular. So if you wanted to sound more traditional, more conventional, you can do that. And we still have our wave folder. So we can still do some pretty tricky stuff. We can use our second function generator to add in some wave folding. So at the very beginning of the note, we can give it a bit of pep, or we can do it at the end. So what we can do, if we trigger, if we trigger our second envelope from the gate, in other words every time we press a key, and we'll put this into the wave folder, you can see that light up. And we'll make it a bit slower. And you can hear at the beginning we're folding the wave, so we're getting that much richer, even richer than the sawtooth. We're getting a rich harmonic, and then it very quickly fades away because we've set that fast, and then we come into our pulse width. So you can hear the note. Now we still haven't played. We can of course change our filter. So by cutting back a few of the frequencies, almost in a subtractive way, we are changing the sound again. So we've got a very complex source now. So the source starts off with the wave folder buzzing. We have our sort of sawtooth wave from our frequency modulator. So the source is changing over time. It's changing according to function 2, our envelope. We can change whether it's a fast or slow attack, and that will have a big effect too. We're filtering out the very brassy, buzzy sounds, and then we've got a little bit of reverb, so we end up with our quite a complex sound actually, and we can still do things like change C. Because remember, the fold is the beginning, and C is the ultimate sound we get when we press. that's given you something to look at with your own Volca modulars. Basically, if you want to sound like a more conventional, more traditional synthesizer, that's the way you can do it. Well, thanks for watching, and hopefully we'll see you at the next video. Okay, bye for now.